Good day and welcome to my YouTube channel. I am Acho Francis Devan. Today we're going to be dealing with mathematics, indices to be precise. If you remember very well, when I was solving questions on general gas equations, I made mention of certain important mathematics topics which we ought to know, which will help us to be able to move around more swiftly in chemistry. Chemistry as a course cannot exist on its own without an efficient knowledge of mathematics. So topics like indices, change of subject of formula, sort, and so on and so fraction, all these things must come into play, number-based system and many more. So today we're going to go through indices to the best which we can to see how we can correlate these things in our chemistry as a whole. So indices or indicial equation is a method of shortening the product of numbers to a reasonable pattern or kind of. For example, if I'm having something like 8, this is 8, or this is 8, and this 8 is the same thing as 2 times 2 times 2. So how then can I shorten this? I can easily say this is 3, there are 3 variables, so this is 2 raised to the power 3. It's a method of shortening what the product of numbers. This is a pattern in which we can shorten it, like I showed you earlier on 2 raised to the power 3. So this trend we can use to reduce any number we want to deal with. For example, if I have 16, which is the same thing as 2 times 2 times 2 times 2, 2 raised to the power 4, so this can just be taken to be 2 raised to the power 4, which is the 16. So, and this trend continues, so on and so forth. But then, most importantly, we have certain laws which we use to govern or to run through these indices. The first one is the multiplication law of indices. Let's take that. Multiplication law of indices states that when numbers with equal bases are multiplied, the powers are added. Their powers are added. Let's take, for example, 1. If I have, this is 1, 2 raised to the power 3 times 2 raised to the power 2 times 2 raised to the power 5. We say when numbers with equal bases are multiplied. Now, these are the bases of the numbers, and these are their index or the power. That is why we call it indices. We're concerned, or we focus more on the power, which is the index. So these are the index, and these are the bases. So when numbers with equal bases are multiplied, their powers are added. Then we will have something like 2 raised to the power 3 plus 2 plus 5, and this is 2 raised to the power 10 as our answer. So in multiplication law is direct. Whenever you multiply numbers with equal bases, we add them. Okay, let's take another example aside this. If I have 2 as a raised to the power 3 times a raised to the power 2, this will become a raised to the power 3 plus 2, which is a raised to the power 5. The trend continues. Now, another aspect of this multiplication law is when we multiply numbers that have different bases, we have to regroup the ones that are similar and evaluate them. Let's take that as 3. I have a raised to the power 2 times a raised to times b raised to the power 3 times a raised to the power 4 times b raised to the power 5. So if you check here, we have different bases. So I have to do collect the like term, those ones that are similar, bring them together. So I will have something like a raised to the power 2 times a raised to the power 4 times b raised to the power 3 times b raised to the power 5. So I have to regroup them. So in this manner, I cannot proceed. So this 2 goes with the law that when number with equal bases are multiplied, we add their power. So here I will have my a raised to the power 2 plus 4 times b raised to the power 3 plus 5. And this is a raised to the power 6 times b raised to the power 8. So this is it. This thing goes in the what? Multiplication law. So if I want to take a real variable that have real numbers, let's see what that becomes. 2 raised to the power 3 times 3 raised to the power 4 times 2 raised to the power 2 times 2 raised to the power 1 times 2 raised to the power 3 raised to the power 1 times 3 raised to the power 4. I will bring them all together by regrouping them. So I have my 2 raised to the power 3 times 2 raised to the power 2 times 2 raised to the power 1 times 3 raised to the power 4 times 3 raised to the power 1 times 3 raised to the power 4. So with this, I have to regroup, proceed, evaluate. So here I have 2 raised to the power 3 plus 2 plus 1 times 3 raised to the power 4 plus 1 plus 4. Don't forget, multiplication law says when numbers with equal bases are multiplied, the powers are added. When also the numbers are mixed up, we have to regroup them and still proceed, which I am doing. So here becomes 2 raised to the power 6 times 3 raised to the power 9. Now, if I want to finalize and get to the answer, it's a whole lot of big numbers, so I have to use my calculator. 2 raised to the power 6 will give me 64 times 3 raised to the power 9 is 19683 times 64. The answer becomes 1259712. So if we're looking for the final answer, we can solve it down here if we want to. But for the purpose of mathematics or indices, we don't mind, we don't care even if you stop here. You're good, we are good. You get here, we understand how you get here. But if you are required to go beyond, you break it down to here. Okay. So let us take the division law. In the division law, it says when numbers with equal bases are divided, the divisor will be subtracted from the dividend. With equal bases, the power of the divisor is subtracted from that of the dividend. So let's take go the other way. So when numbers with equal bases are multiplied, the power of the divisor is subtracted from that of the dividend. So now, I have in the division law, so number 1, 2 raised to the power 3 divided by 2 raised to the power 2. This becomes 2 raised to the power 3 minus 2. We subtract their powers. The power of the divisor is subtracted from that of the dividend. This one is subtracted from that of the dividend. So this is 2 raised to the power 3 minus 2 is 1. 2 raised to the power 1 is 2. So this is our answer. Let's take another example. Let's call it example 2. A raised to the power 7 divided by a raised to the power 3. This is a raised to the power 7 minus 3. This is a raised to the power 4. This is your final answer. So that is it. In another way, if you want to break it down further, this a raised to the power 7 will become a times a times a times a, 1, 2, 3, 4, times a, 5, 6, 7, divided by a raised to the power 3, a times a times a. So if I cancel this divided by this, we'll go. I'm left with 1, 2, 3, 4. So this is a raised to the power 4. So this is another way to break it down. But we always appreciate this because if you're dealing with elaborate numbers like a raised to the power 25, you're not going to be writing this all through. So it's going to take all of our time. So we try to cut it down to use the simplified method of solving it. All right. So there will be cases where you will likely going to get a negative value in when you do this. Okay. Let's take another example 3. If I have something like a raised to the power 2 divided by a raised to the power 5. This is a raised to the power 2 minus 5, and this is a raised to the power 2 minus 5 is minus 3. Now, this isn't all, but because we are still in division law, I cannot solve it further. Let's presume we do not know more than this, so we stop here. But this is found in the negative index law. When we get to negative index law, you understand that the answer doesn't end here. We're supposed to move further, a step further. But we're going to be patient till when we get there, we see how we're going to go through that. So this, for the time being, this is our answer, all right? So this is the division law. We have another law called the Powers law of indices. Let's take that Powers law. Now, in the Powers law of indices states that when a number is raised to a certain power, which is again raised to another power, that number is said to be in powers. That the powers are multiplied together for final evaluation. Let's see what that implies. Example 1. When the number A is raised to a certain power B, which is again raised to another power C, this number A is said to be in powers, that the powers are multiplied together for final result. So this becomes A raised to the power B times C. This is A raised to the power BC. This is our first example. Let's see what we can do further. Let's take another example. Example 2 here. 3 raised to the power 2 raised to the power 3. This is the same thing as 3 raised to the power 2 times 3. This is 3 raised to the power 6. This is Powers law. When a number is raised to a certain power, which is again raised to another power, that number is said to be in powers. That the powers are multiplied together for final result. Okay, let's take another example here. 2 raised to the power 3 raised to the power b. This is 2 raised to the power 3 times b. This is 2 raised to the power 3b. So that is our answer. And so on and so forth. Even if we take this again, number 4, as 5 raised to the power 2 raised to the power 3. This is 5 raised to the power 2 times 3. This is 5 raised to the power 6. So we move on. So these are the basic examples. We can do this on and on and on and on. So I get a lot of examples. Let's look at another product power law. When the product of different factors are raised to a certain power, when the product of different factors are raised to what? A certain power, perhaps in the bracket, yes, the power is distributed over each other in the bracket. So when the product of different factors in the bracket are raised to a certain power, that power is distributed evenly to all the variables in the bracket. Let's take that. This is product power law. When the product of different factors, let's call it A, B, C, are raised to a certain power, that the power is distributed evenly into the various variables in the bracket. So this becomes A raised to the power 2 times B raised to the power 2 times C raised to the power 2. That's it. So we can equally say A squared, B squared, C squared is the same thing. These two are the same. So what if, let's take another example. This is 1, example 2. If we have something like 3B squared, that the power will be distributed evenly in it. So I'll have 3 squared times B squared. 3 squared is 9 times B squared, which is the same thing as 9B squared. Another example, 2 B raised to the power 3. This is 2 raised to the power 3 times B raised to the power 3. 2 raised to the power 3 is 8 times B raised to the power 3. This is 8B cubed. Now 2 raised to the power 3 is 8, being that 2 times 2 times 2, which is 2 raised to the power 3. 2 in 3 times. 2 times 2, 4. 4 times 2, 8. So 2 raised to the power 3 is 8 at all times. So this is the product power law. Let's look at the zero index law. The zero index law says that any number raised to the power 0 is 1. Let me take this out. So I have the zero index law. Number 1. Any number raised to the power 0 is 1. Example, 3 raised to the power 0 is equals to 1. 2 raised to the power 0 is equals to 1. 9,100 or 1,000 raised to the power 0 is 1. 1 million raised to the power 0 is 1. A raised to the power 0 is 1. B raised to the power 0 is 1. Anything raised to the power 0 is 1. So we don't have to forget that. It is important because we're going to make use of it. We're going to apply it. There will be certain times where we're going to get across such things. If you don't remember the formulas or the laws, you find it difficult to break through that step. So it is important if you can apply all the laws at all times, you remember them, then you can get through without much trouble. Let's see, we're done with that. The root power. This power involves the method of showing the indices of different roots. So we show the indices of different roots. Let's take the first one, the root power. This method involves showing the indices of different roots. 2 raised to the power 1 over 2 shows the square root of 2. 2 raised to the power 1 over 3 shows you the cube root of 2. 2 raised to the power 1 over 4 shows you the fourth root of 2. 2 raised to the power 1 over 7 gives you the seventh root of 2, on and on. So the root, this is what gives you the root. It shows you the indices of different roots, and that's all. So at all times, you should know that 1 over 2 is the same thing as square root. 1 over 3 is the cube root. 1 over 4 is the 4th root, 1 over 7 is the 7th root, 1 over 5 is the 5th root, and so on and so forth. We can do that. Let's check again if we have more. Okay, fraction index. In fraction index, say at times a number might be raised to the power which is fraction other than half. Remember, okay, the method of resolving this is by finding the value root, the end root of the denominator. All right. So in this case, it may not necessarily be 1 over 2. So what's the name again? Fraction index. Let's go there. It shows you the end root of numbers, which may not necessarily be what? 1 over 2. So let's take examples. 4 raised to the power 3 over 2. Number 1. 4 raised to the power 3 over 2. Now, what is down here forms the root. And here we have 2, so it's square root. So this becomes, since this is square root, this is my square root of 4 raised to the power of 3. What is up here? Give us the power. Here down, give us the root, and this is our 4. So, and that is, if I want to simplify this, the square root of 4 is 2 raised to the power 3, and this is 8. So this is first step. So let's look at the second question. 4 raised to the power 5 over 2. Remember, what is down here is our root. So the root is square root. So this is the square root of 4 raised to the power of 5. And this is the square root of 4 is 2 raised to the power of 5. 2 raised to the power of 5 is 32, if I'm not mistaken. How do we get that? 2 raised to the power of 5 is 32. Remember, I told us earlier on, this is 2 times 2, 3, 4, 5. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. That is how we got that. Okay, let's take another one. 8 raised to the power 4 over 3. 8 raised to the power 4 over 3. Now, this is the cube root of 8 raised to the power of 4. And this is, the cube root of 8 is 2. But how will I know that? There are many ways we can use our calculator to press that. You press, okay, the second function root 8, which will give you 2. But we can also use Powers' law to break that down, okay? So now we know that the cube root is the same thing as 1 over 3. 1 over 3 means cube root. I have illustrated that earlier on. Then, let's see how can we do this without using our calculator, all right? To see how we turn the cube root of 8 to be what? 2. Now, this is it. So, the cube root of 8. So this is my 8 raised to the power 1 over 3. Remember, that is the same thing as the cube root of 8. This is the same thing as that, which is this. So I want to break this down before I bring the power. 8, according to Powers' law, means we talked about the shortening of the product of variables, isn't it, as indices, generally. So it means this 8 can be also written as 2 raised to the power 3 is 8. I can multiply it 2 by itself 3 times, I get 8. So this is now raised to the power of 1 over 3. So I have transformed it into the Powers' law of indices. And what does Powers' law say is that when number with equal bases are multiplied, their powers are added. Sorry. Powers' law says that when a number is raised to a certain power, which is again raised to another power, that the number 2 is said to be in powers, and the powers are multiplied together for final word result. So I will have 2 raised to the power 3, which is here, multiply their powers for final result times 1 over 3. So this is 2 raised to the power 3 times 1 is 3 over 3. 2 raised to the power 3, 3 divided by 3 is 1. 2 raised to the power 1 is 2. So that is why the cube root of it is 2. I can use Power's law of indices I can apply any law to solve anything I want to solve based on what indices. So if that is true, my next step becomes 2 raised to the power 4. And this is 16. 2 times 2 times 2 times 2. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. That's how I got there. Okay, I think we're progressing. Let's take another one. That's one, negative index law. It says a number raised to a negative index equals the reciprocal of that number raised to the same positive index. Okay, let's take, where is it? Let's take some examples, all right? Okay. 3 raised to the power minus 2, negative index. 3 raised to the power minus 2. Negative index law states that a number raised to a negative index equals the reciprocal of this number raised to the same positive index. This minus 2 become positive. First, let's break it down. Now, this is equals to, I want to solve this, but let's, excuse me, let's take a unique approach to understand what we're saying. Now, they say a number raised to a negative index, okay, equals the reciprocal of that number. Now, this is 3. What is the reciprocal of 3? This is 3 over 1. Every 3 you see in the wall, every number you see in the wall is over 1 because it still gives you the same number. So, if I have 5, it's the same thing as 5 over 1 because 5 divided by 1 is 5. 3 divided by 1 is 3. So now, this is it. The number is this, but this is how it exists. We know it. Technically, we know that. So now, if this is the same thing as 3, now what is the reciprocal of this number? It's the same thing as 1. The reciprocal becomes 1 over 3. Okay? So this one now will be what the reciprocal is 1 over 5. Because I know that this number 10 is the same thing as 10 over 1. The reciprocal of 10 is 1 over 10. So you must begin to see these numbers in a different dimension to understand that there is a 1 down there. It's divided by 1, I give you the same thing. So if this is true, the law says that when a number is raised to a negative index, it is equal to the reciprocal of that number raised to the same positive index. Okay, now, this, I want to put it down. 3 is raised to a negative index. Now, what is it? It is equal to the reciprocal of 3, which is now 1 over 3, raised to the same positive index. What is the negative index before? It was minus 2. And I say raised to the same positive index, it becomes what? Plus 2. So I have the power to put 2 here. Raised to the power 2. That 2 is positive. That is what the law says. When a number is raised to a negative index, it is equal to the reciprocal raised to the same positive index. The negative index becomes positive index. The number itself, you get a reciprocal of it, and we move on. Yes, it's clear. So this is the same thing as 1 over 9, because 3 squared is 9. And so on. Let's take another example, in case we don't get this well, we can understand it that way. Let's look at another one. 5 raised to the power minus 4. Example 2. 5 raised to the power minus 4. This is equal to, when a number is raised to a negative index, that number, it is equal to the reciprocal of that number raised to the same positive index. What is the reciprocal of 5? Is 1 over 5. Now, this 5 was raised to a negative index, which is minus 4. They said the reciprocal of 5 now is raised to the same positive index. The positive index of minus 4 becomes 4. So this is equal to 1 over 5 raised to the power 4, should be 6 to 5 also. Okay, 5 raised to the power 4, 6 to 5. 6 to 5. These laws can be confusing if we do not follow the rudiment in studying it. It may looks difficult or confusing, but it is important that the laws are there. When we follow the laws the way they should be followed, this whole thing becomes simple. We enjoy it in a different way, okay? So I've been able to explain the basic laws which we need in indices. So we begin to take questions to see how to apply the laws.